So this is our little model of neuron action potential. To start off, the cell is in resting state. Sodium and potassium gates are closed, and the resting membrane potential is around negative 70 millivolts. After there is a stimulus, the voltage gate sodium channels open, and sodium ions begin to flow through down their concentration gradient into the cell. The potassium channels will remain closed at this point. As the sodium travels through, the influx of sodium ions changes the membrane to potential to about negative 55 millivolts, and that triggers the action potential, which basically causes the neuron to go through its firing and sending signals. If it doesn't reach negative 55 millivolts, the nerve will not fire, and you won't have any response. Once the action potential triggers, the membrane becomes depolarized, and that initiates the potassium gate to open, and that allows the potassium ions to flow out of the cell, again following that concentration gradient, to repolarize the membrane. However, the potassium gate does not close when necessary, so more potassium than is needed actually flows through. So once that happens, you get the membrane essentially going too far into the negative to as the potassium flows out. So it must use active transport through an ion pump essentially to move the ions back and reset to fire more signals as more stimuli occur.